The body has a defense mechanism against any foreign object or medical device. This can be a problem, and it's a temporal response, so it changes over time. So first the body tries to remove this object, and if it can't remove it, it starts to isolate it. So it lays down dense connective tissue or scar tissue that really excludes it from the body.
Right now, only 10% of people with type 1 diabetes use the most advanced delivery system, which is an insulin pump. The reason for such low adoption of these insulin pumps is due to the short lifespan of the infusion set cannula. The infusion set cannula typically only lasts 3 days, and this is due to being blocked by the foreign body response, which then prevents much needed insulin being delivered.
So we started this collaboration a number of years ago between Professor Ellen Roach's group at MIT, Professor Gary Duffy's group here in Galway, and myself. That's kind of where we started to explore this technology.
Yeah, we've been working with Ellen Roach for a number of years now, and we've been working on a number of different studies. This study came about by initial discussions of when we had a failure in our device, how do we overcome it? And at the same time, Ellen was developing her Solve robotics expertise, or that whole team in her lab. So we thought about applying that for this specific problem. So we thought if we actually made the device softer, so it wasn't a rigid implant, and then if we actually moved it, so movement akin to inflating and deflating a balloon. Same idea here is that you inflate and deflate the surface of the device, and then you try and interact with the body to reduce its response to the implant.
And we showed that it worked. At 2 weeks, the thickness of the scar tissue that formed around the device was less in our actuated group compared to our control. So in our new study, we have generated really exciting results. So in the initial paper, we looked at 2 weeks. Now we've extended it out to 8 weeks. Our device at 8 weeks performs similarly to a device that was just implanted for 3 days.
So we're looking at the unique ecosystem in Galway here and trying to see what are the next steps to getting to the patient and making sure that we have that impact.
It's been a super collaboration working with such a multidisciplinary team, and we're all bringing different aspects to the study, and everybody's very passionate and really believes that this technology will work and make a difference.